Alright, so here's another example with Dijkstra's algorithm. And so we've got a pretty complicated little graph here. We've got 7 nodes, I believe: A, B, C, D, E, F, and G. We have edges attached to each of those. And so remember how it starts. We just go ahead. I'm going to try to fit it in here on the side. A, B, C, D, E, F, G. Okay, and then we're going to start with A, and then distance from A to A is 0, of course. Okay, so then distance from A to B gives me the 7 here, so I'll put a 7, and like I said before, I like to put the A there. And then A to C, it looks like is 1, and then 1 to D, or A to D is 10. A to E is 11. A to F is not connected, and A to G is not connected. Good, so there's our first row. Okay, this is our minimum here, so our next node is C, and we bring down this guy. Good. Now C is connected to A. Yeah, those are already finished. Remember that A is now a done node. You could even kind of cancel that out. We're done with A. And so now we're focused in on C, and it looks like C is going to be connected to E, and I think we've already gotten everything else, right? So C is not connected to B, so therefore I just bring the 7A down here. B or C is not connected to D, so I just bring the 10A down. C is connected to E with a weight of 10, and so we add the 10 to the boxed value, which is 11, and so it looks like we have two 11s here. We could either have 11 from A or 11 from C. Okay, and then C is not connected to F, but it is connected to G with a 16. So 16 plus 1 is 17, and then we put a C there. Good. And now we bring the minimum down. 7 is going to be the minimum. And by the way, C is now finished. And now we're working on B. So node B. Good. So B is over here connected to D with a weight of 2. 2 plus 7 is 9. So this is going to be a 9 with a B. B is B connected to E? No. So I just bring down the 11C. Okay. Is B connected to F? Yes. With a node of 9. 9 and 7 is 16. So therefore this will be a 16 coming from B. B is not connected to G, so the 17C comes down. Good. Alright. Now the minimum is the 9. Oh, by the way, the B is done now. Okay, so now we concentrate on D. Bringing D down. Oops. D comes next. D to E is not connected, so 11C just comes down. D to F. D is not connected to F, so the 16 comes down from B. Is D connected to G? D is connected to G with the 7 there. 7 plus 9 is 16. 16 is less than... Wait a minute. So we put our 16D down here. I'm running out of space in here. D. Okay, now you're going to move that over a little bit. So you can see that's 16D. Okay, and we have a little tie there. So now next we'll bring down our, so now D is done. So you could take D out of consideration. And now we work with node E11, which bring down the 11C there, E. Okay. Is E connected to F? And it is, with a weight of 11. 11 plus 11 would be 22, so that's more than our 16, so we just bring down the 16. Okay, and then is E connected to G? It is with a weight of 4. 4 plus 11 is 15, so that changes that. That's less than 16, so 15 with an E. Good. And actually that makes that one our minimum now. We could take out the E if we wanted to. E is now done. And we bring down our 15 with the G. Okay. And now is G connected to F? G is connected to F with a weight of 3. That would give us an 18 though. 18 is bigger than 16, so I just bring down the 16. Okay, and so that leaves 16B down here at the bottom with node F. Very good, there we are. So, for example, if we wanted to go from node A to node F, which direction would we go, and how much, or what would the path be, and what would it cost? So path from A to F, well, the cost would be 16, and the path would be, I'm putting the last node at the end here, and then this is telling me to come from B, and then if I go up to B, this number was telling me to come from A, so it's just ABF. And so over here, let's see, so we would go from A to B to F, and so that's our 16. Good. All right, so that is another example of Dijkstra's algorithm using this little tabular form.